So now in this video, we're going to look at the emitter follower. So it takes a voltage, the voltage in, and for the most part, that is the voltage out as far as the load is concerned. But since we're going to use an NPN bipolar junction transistor, it doesn't really work with the PNP bipolar junction transistor. So we're just going to look at the NPN in this case. We're going to use the 2N3904. And so it may have a different pin layout if you have a different transistor than what I show in this video. But in any case, the load goes to the emitter. The collector goes directly to the positive side of the power supply. And then voltage in is usually a weak voltage. We're going to use a trim pot in this case. It's a 10 kilo ohm trim pot, and it'd be very hard to set a voltage across an LED that needs a significant amount of current. So the signal does not provide the current needed to power the load. It just sets the voltage, but we have the base to emitter diode drop, and so it'll be about 0.6, 0.7 volts lower at the emitter. We have another resistor here, so you'll see this, I think, in every simple schematic for an emitter follower, and it just helps hold that voltage because sometimes the load will confuse things a bit. But if you have a 10 kilo ohm resistor right here, you should hold the voltage pretty well. For our demonstration circuit, we're going to build this one right here. So we just added some values for the most part. We added an LED instead of just a generic resistor to indicate a load. And as I said before, we're going to use 10 kilo ohm resistor as an emitter resistor. The trim pot is going to set the voltage. So as I said before, you wouldn't want to use this 10,000 ohm trim pot to set a voltage directly across a current limiting resistor and an LED. This will, unless you go directly to the positive supply for the most part, this will have a lot more resistance, a lot more impedance. It can set a voltage but can't provide current. So basically it tells the transistor to start conducting until the voltage builds up there. That is about 0.6 volts less than at the base. So we have it on the board over here. This is a 2N3904, so you can see it went to the middle pin. That is the base, middle pin there. You can see flat side here, the emitter to the left, the base in the middle, collector to the right. And so if I turn it this way, now it lines up with what we see on the board. Again, if you have a different transistor, especially if it does not start with 2N, it may have a different pin layout. The top pin, the collector directly to the positive supply. We don't want to impede that at all. And then the emitter to the 10K resistor. So the 10K resistor is off to the right instead of the load. Remember, schematics just tell you where to make the connections, not how to lay them out on the board. So we got the 10K coming over there. So now we'll grab the resistor and LED. I'll do the LED first. It's coming to this gray jumper, the shorter lead. The longer lead, the anode, going up one row. Shorter lead is the cathode. And we will grab the 220 ohm resistor, again going to the emitter, and our circuit is done. I have the power supply set to 5 volts, but the output is off at the moment. Now the output is on, and you can see that we don't see the LED glowing at the moment. I'm going to go to the negative rail, so that's 0 volts. We have to get the forward voltage of the LED plus the diode drop from a base to emitter. So we need somewhere about 3 volts or so before the LED will light up. And there you can see we can set the brightness. But most importantly, we're setting the voltage. So let's grab the oscilloscope. There's 5 volts, in case you couldn't see it. We'll grab the oscilloscope so we can actually see the voltage. And so we got the oscilloscope. The cable comes to these alligator clips. I just clipped them to jumpers so I can move them in the board where I want. Our reference voltage is 0 volts, the negative side of the power supply. And then we got the red jumper we'll put directly to the positive supply. Each square going up is 1 volt right there. I'm going to go to the emitter, where the emitter resistor and the load are right there. So it's a little more than 2 volts right there, which makes sense. The LED is really not lit hardly at all, pretty dim. And so what I'm going to do, I'm going to raise it to 3 volts just to make things easy right here. And you'll see that when we got 3 volts at the emitter, if I come to the middle pin anywhere the middle pin is connected, we got that little jumper there, you can see it's about 0.6, 0.7 volts higher at the emitter right there. So if I want to try to get 4 volts, I'll have to go up about 4.5 right there, and then we'll go down just a little bit more, and now we should have pretty close to spot on 4 volts at the emitter. So you can go either way like that, and that worked pretty good. The jumper, I think, is just a little loose right there. That's why it's a little wavery. But in any case, if we get these connected a little better, it should clear up. There we go. So that's really it for the emitter follower and how to notice it on a schematic. It's just simply the load is from the emitter headed to ground right there, and then you'll have most likely a 10 kilo ohm resistor also headed to ground to help ensure that voltage in case you have a tricky load. And that's really about it. So hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen. Click like, subscribe, the bell, all that. If you can donate, I put those links on the top. That would help out a ton. But watching videos also helps a lot. I appreciate that. I'll see you in the next video.